Hello everyone, I'm sorry for not updating for so long. So in this video, I want to share with you my framework, which I didn't realize I have one till I start talking to my mentee about their project. So the way to think about how to design a project, what factors you should consider, and why you should consider that way, and how to keep everything manageable when you given the job opportunity you are looking for. I roughly structured the content into 3 questions. The first one is, what are the basic elements you should think about when selecting or designing a project? The second one is how those elements decide the difficulties of the project, which means the time it takes and how much frustration it may cause you. And the last one is, if you are a beginner, how can you design a project that you can easily get started? And if later on you decided you want to do more complicated elements to this project, how to add on without overhauling the entire project without too much sunken cost, so you can delay your decision and still have a good quality of the work. So number 1, what are the basic elements to think about when you're choosing or designing a project? The first one is the nature of the task. The second one is your data source. And the last one is the technology you want to practice or demonstrate. Let me go through each one. The nature of the task is the very first question you need to answer and make a decision. Because if you think about all the decisions you need to make when designing a project, this is the number 1 element, because it will decide the data source you're going to use, the model you're going to use, and basically everything in the pipeline of your workflow. So what do I mean by the nature of the task? So if you look at the domains in machine learning or deep learning, they are organically categorized by whether it's an NLP task, a CV task, or it's a more industry-oriented, it's a recommendation system, it's spammer, it's a sentiment analysis. So if you kind of have an intuition, okay, am I doing which big category of those tasks? Then you can start asking, what is the data format? Is it text, audio, image, 3D model, videos? And if you realize you are attempting a very complex task that you may need to break it into several steps, you may want to rephrase the problem. So for example, I have a mentee who initially want to do a mask on nude photos for each nipple. We need to put a mask so we can upload the photo to the public library. Initially, the project is designed to be a segmentation problem. However, then we realize she has a lot of gaps in the technology, in the architecture of the models. Then we decided to rephrase that problem into a classification problem rather than semantic segmentation, which has more complex structure, and the data preparation is a lot more complicated. So basically, you need to understand what are the types of tasks there in the deep learning models and understand which category and the subcategory of these tasks and see how other people did it. The second most important factor is your data source, whether it's raw data you collected from your daily life. For example, I have a mentee, he just wanted to classify pancake and waffle. So he just took 30 photos in his personal life, and that's enough to have a 90% prediction accuracy. So when you think about the data source, you first can ask, do I want to prepare it myself or not? What is the data format? Is it a text, image, audio? Again, every single source of information you can think, but you need to prepare yourself that each data format has very different technology to process, which depends on the nature of the task. For example, for a same image task, if you just see it as a classification problem, it's just a matter of label the image title properly. However, if you phrase your problem as a generated description of the image, that involves not just the image anymore, but also NLP tasks. And potentially, if you want to locate what you identified, how you interpret in this model for the debugging purpose, there will be very complicated data prep. So when choosing a data source, try to first have an understanding of what processing that may need to happen on that data format before you can fit it into the model. And ask yourself, do you want to put that that work into processing the data. The last one is the technology you want to learn or practice or demonstrate, just put on your resume to prove I have done this, I'm familiar with this. If you don't even know what technologies you want to learn, you want to demonstrate, you can first go to collect your ideal job description, see what job market is looking for. And second, there is a website called Workera, and they have a very detailed evaluation of each of your skills. And last one, there are tons of materials online. You can find what is trending, what is well used, and pick that one. Now you know all the elements you need to consider when designing a project, but if we zoom in, have a high resolution of each factor, how the decisions inside each element can decide the difficulties of your level. So let's go through each element again. The very first one is the nature of the task. You can think it as two sides. One is your personal interest. A lot of people just genuinely interested in NLP task over computer vision, and some other people are the opposite. And take that into consideration. If you are not interested in learning that kind of task, you won't be motivated to understand, okay, what is the positional embedding? What is the different ways of tokenization and how the bounding box is calculated? If you are not personally interested in that type of task, you probably won't drive further enough to understand all the details to deliver a good quality of work. So that's the big factor. Don't ignore your personal interest. And second, look at the overall maturity of each task. For example, classification or regression is like the most bread and butter level type of task. So if this is your very first project, I highly recommend just to start with there so that you don't get yourself frustrated and you can deliver something and you can poke around and start asking more specific questions rather than just watching a bunch of advanced topics without hands-on experience. Once you have done some basic classification regression problem and you have a basic understanding, okay, how the data flow through the network, how the backpropagation happens, how to understand the computation graph, and how to use the API of the library you chose. Once you have a basic comfort with those, then you can start doing things like, let me do a recommendation system, let me do a chatbot, let me do basically something that you can share with people who don't have a basic understanding of deep learning. If you talk about the term classification or regression, people outside deep learning basically can't resonate with you. They wouldn't really understand what you are talking about. But more advanced project, they actually have a more real life shared understanding. To have an understanding of what types of tasks are out there, there are many ways. You can read through system design blogs from educative or different engineering teams from big tech, or you can look at those popular courses from Stanford, from Coursera, and see their catalog, what types of tasks they covered. You don't even need to take those courses, which you should, but to have a basic understanding, you don't need to. You just look at the course catalog, syllabus. Or you can just think about how those popular software work, like to make Twitter work, to make Instagram work, to make YouTube work, to make autopilot car work, what questions can possibly be asked, and start Googling and searching. And sooner or later, there will be some concept or tasks surfaced, and keep digging into that direction. Basically, you are trying to balance between things are too challenging and things that are too, you think are too vanilla for you. It's not worth your time to going through all the steps. However, to make this trade-off properly, it really depends on where you are in your journey as a machine learning student. I'm not saying the school student, but a student for your career. One interesting thing is if you chose a mature task, you may not even need to train the model. It can be used to make a decent prediction right off the shelf. Okay, the second element is the data source. When you think through the preparation of the data, you first want to ask, is this data actually available? Like sometimes we think we want to do, let's say, a deep learning model that can convert a 2D image into a 3D cloud points model. Then you need to know if those data formats are available, and if they are not, how can you possibly collect them? Or you may want to do a stock market trading algorithm for your paper trading. You just don't have the most recent data. And don't get frustrated. There are many interesting problems you can solve. Is to find the one that you do have data. There was a while I was trying to build a machine learning model to count how many hairs I have per square centimeter on my scalp because I was trying to improve the density of my hair because I'm getting older and my hair sheds a lot. Initially, I thought it's a very complicated project because I don't know if there are data available for that and how to design the benchmark of the data. Then after some researching, I learned that you don't have to go to spa or hospital to have those fancy machines. You can just buy those $30 special camera at home and take a photo of your hair and count that way. And there are also tons of research papers have published what are the baselines of those data. Then it suddenly became an easy project. So my point is sometimes the data source will be harder and sometimes the data source will be a lot easier than you expected. But what usually makes people frustrated is they reached their conclusion without doing the investigation work. And then there is a clash between the reality and their expectation. Okay, my camera just decided to turn off itself. Anyway, my point was sometimes the data prep will be easier than you think and sometimes it will be harder. So try not to set your expectation yet before you did the investigation work of what it actually takes to prepare the data. And you don't actually need to manually do them, but you need to have a basic understanding. Okay, you can see the step by step to the level the data can be fed into the model. It's kind of like a venture capital pitching. You don't have to build the company yet, but you need to clearly show the evidence that you know how each step gonna happen. Maybe that analogy is a bit far-fetched. So sometimes you may need to write an image filter to get the outline in this image. Sometimes you may need to write a program to parse your PDF file. Sometimes you need to write a filter for your audio data to remove the wavelength. Sometimes you may need to crawl the website. You need to make the decision, do you want to put the work to do those steps, or do you want to, as your first project as a beginner, you want to really focus on the machine learning part. So this is where you decide, am I doing this more for job application or am I doing this really for my own learning and I want it to be fun. It's also worth your time to look into what data prep tools out there. For example, there is Scale AI, which is not designed for individual, it's for company. And there are Segmentation AI, and there are many other tools. So it depends on the nature of the task. You already decided in the first step and how mature that task is. You may need more diversity in your data. You may need a larger data size. Basically, for each step you take along your project, always be ready that you may need to go back. And once you get comfortable with that, you just save your energy in getting frustrated compared to you can actually sit there and learning and trying to figure out how to fix the problem rather than get drained from those problems. Okay, the last part, the readiness of your model. This is kind of tied to the first element, which is the nature of your task. But sometimes you can find a model that does exactly what your task does, and you may want to jump on and using that model. The problem is, especially if you find those models on GitHub, if they are 2 years old, you may need to spend several days to trying to fix the dependency conflicts. It just can be a circular loop if it also involves some deeper level library that are running in a different Linux system in your local environment. So that can look like the model is ready, but in reality it's not. And there always can be tiny issues pop up when the whole model isn't designed to be used by another person. Like their requirement of the data format, you may need to spend extra time to preparing data, although you thought you already did. So usually I don't recommend that route, although it looks easier. And the second route is to first understand the nature of your task and find a model that does the same type of task on Hugging Face or Paper with Code, because those models are designed for other people to use, which means they have good documentation, they are updated, and they have a community people you can ask help for. Also, those models usually they are named by the nature of their task. But still, they may not match exactly the task you want to do. For example, the model has two heads. One is predicting a certain, the centroid of object in the image, and it has a second head that to predict the feeling, the mood of the image. But for you, you may want a third task, or you may want to remove just one task, how to do that through the API they provide, or you have to change their source code. And does that affect your preparation, or if you feed batches of data into the model, does it affect your data loader? So because of those reasons, and also if you are a beginner, I usually recommend the last route, which is actually to build the model from scratch, which counterintuitively is actually a lot easier than find a model that's ready to use, that's seemingly ready to use. And the reason is, when you build a model from scratch, it means you really understand every single piece. It may not be complicated, which it shouldn't be, but it's a lot easier for you to further develop this model or debug when anything wrong happens. So basically, you are going a more naive and simpler way, but you can deliver a complete project compared to if you use some ready-to-use advanced model. If anything went wrong and you don't know how to ask a question, you don't have people next to you let you ask those questions, you can get stuck and you feel like all your days, weeks of time is wasted compared to you build a model from scratch. Yes, it's slower, it's more vanilla, but each step is very solid. It's less likely you have to go back to abandon all the work you already did. Okay, the last part. Now we sorted out what are the elements you need to consider when designing a project and how each element affects the difficulty level or the overall time cost of your project. But how do you approach them overall? If you just think each element one by one, it's like building a Lego from scratch, like designing each piece by piece. It's still overwhelming. So usually I suggest 3 levels of project I tend to recommend, and the second is how to modularize the complexity so that you can do the core part, the part you are most interested in, and after you have done that, you can add complexity to your project. So for the first question, overall, I see them as 3 levels. The first one is to just do the project not for your job preparation, just for the sake of learning something, of getting something out of the door shipped. Think of a problem, a question you're genuinely interested in that you really understand the problem. Like, for example, if you jump on a Twitter design, like you don't intuitively motivated or understand the nature of the problem, like you wouldn't ask, okay, what if there is a time delay, because it just never really mattered to yourself. So if you start with a personal project where you do it more for fun, you will start asking interesting questions. And that kind of curiosity and a deep dive will reflect on your project document in the end. So usually you can discover very easily in your daily life. For example, for me, it was a hair problem. I want to grow my hair and I want to count the follicle of my scalp. And for you, it could be, okay, I want to have a model that can detect is my voice or anything that just genuinely interests you. The goal of this project is to keep it as small and manageable as possible to get something shipped, which means you probably want to stick to classification type of task because that's the easiest type of task to do. And the second stage of the project is to do a project for the purpose of getting very familiar with the detail of the technology. For example, you may want to do a project where you define your own cost function, or you want to learn how to tokenize text data, or you want to understand how the audio processing happens, or how to hook up the output of one model as the input of your second model. Like, figure out the hard part of the technology you really want to learn and design your project towards that. If you want to be familiar with NumPy, with Pandas, with scikit-learn, then look up what API they provide and find a problem to fit into the tool they provide, following Kaggle or Paper with Code or some up-to-date GitHub repo, and just trying to reproduce what other people already did and learn why they chose to process data that way, why they designed the steps that way. It's kind of like an artist. You are mimicking other advanced artists, but along the way, you're trying to understand why they did that way. And once you get your personal interest satisfied and learned the actual nitty-gritty detail of each technology, you can go to your third project, which is a more real job type of project, which means it involves a lot of data schema design, data processing, pipelining, those kind of things, compared to, because in real job, the actual part of training the model is a teeny tiny part, although it's like the most fun part most people sign up the job for. So in this third project, you can design a project that purposely mimicking the tasks involved in real job you are paid for, which could involve database design, data testing, data reporting, feature engineering, CI/CD pipeline, the deployment to the cloud computers, and versioning control of your data model besides your code, all those engineering side of things. If you still find those steps overwhelming, I modularized the work this way. You first do the most core part that you intuitively identify as machine learning work, which is your Jupyter notebook, and load the data, train the model, make prediction. That's it. That's a core part. Then once you've done that very code level core part, then you can do a demo, a local demo, where you set up Streamlit, and there are other tools to have a web page demo of what you have done. Basically, you did your work, but you still need to do the work to pick other people's interest to read what you did, besides a well-commented code base and a clear report of what you did. So after those two parts, after you've done your core part, your local demo, the third step you can add complexity to is to migrate everything to cloud computing. You can set up your EC2, you can have an endpoint deployed for your UI demo. You can design a gateway endpoint to send real-time data from your local computer to the computing, then send it back. So there are many elements to add on besides the training, the model trainings part. And if after this stage you still want to keep working on the same project, you can start thinking, okay, this project is maybe using a very large model or is a little bit far away from like something tangible, then you may want to do some model compression or even change the framework of your model so that you can deploy it to your edge device, whether it's your mobile phone or Google Cora or some tiny ML device. That way you have this complete circle of not just the software of experience, but also the real hardware, like you can touch them, the real hardware part of the experience. And if after this, you still want to add more complexity, you can look into the possibility in your project. Does it make sense to have more data, to have larger, scalable, like distributed training or federated training, and you want to implement this? Then after this point, it's pretty much done of all the big components you can think about in a machine learning. However, in terms of the engineering side, in terms of the maintenance of your code base, that's a whole slew of its own problem. And these are the levels of complexity that relatively modularized, that you can do one part, then decide if you want to continue doing this and add it on. Or you may decide, okay, I'm done with this project. It's not that fun as I expected. Then I want to move to another project. So that's all for today. I feel I still rambled a lot, but I hope you find it helpful. If anything I said is confusing or you have a very specific question, please leave the comments and I will try to answer them as much as possible. See you in the next video.